Hello everyone, and welcome back to Zeus Tech. Hey guys, so today in this video, we're going to be talking about polynomial regression. And this video is going to be the last episode of the trilogy we've been making for different types of regression. Now, I really enjoyed making these videos, so if you guys did as well, please let me know in the comments down below, and I'd be sure to read them and try making some new ideas for trilogies based off what you guys say. Now, let's begin, shall we? So, I'll say the advanced definition before the simple definition of polynomial regression, like I usually do in these trilogies, like you've seen in my past two episodes. So, the goal of polynomial regression is to model a non-linear relationship between the independent and dependent variables. And that's it. You guys may be surprised. That was pretty short. But even though it was short, it probably was still pretty confusing. So let me show you a simpler definition, which is a bit longer, but at the same time, it's a little bit easier to understand. So polynomial regression is to find the relationship with a dependent and independent variable like linear regression does. But the difference is the way that the data looks on a graph. So it's basically the actual values of the data that's displayed on the graph. Now, on the screen right now, there should be an example of what polynomial regression is. And you guys may be really confused, like, how does that work? Why is it all curvy and stuff? Well, that's what polynomial regression is right now. So this graph doesn't have any labels, but you can see how it starts up high, but then it goes low, then high again. And now, let me show you an example of polynomial regression, but with a linear regression line. So on the screen right now, it should come up, and it's position levels to salary. This seems to be a pretty common example, as when I was learning polynomial regression, I was doing this as well. So as you see, at first it doesn't really go up, but as the ranks go up, it exceeds magnificently. And you see, for the regression line, you can't really show this. Say that we were to actually make a prediction, like, okay, at job 2 or job 1, what would be the value? It'd be completely off. And if you guys want examples of that, in the future, I'm planning on making some programming examples of polynomial regressions and just different types of regressions. So look out for that, guys. And if you guys want to, be able to see those, be sure to subscribe and turn on the post notifications so you guys can stay notified whenever I release a new video, so you can see that when that comes out. Now, so you see here that it says bluff detection model linear regression, but look how it's rising. Look at that difference. I've explained how it increases as the job increases, but not that much until the end. And this regression line doesn't show it at all. So that's why we need polynomial regression. It's for these certain examples where you guys won't be able to plot it or make it with a linear regression. But if you guys did it with polynomial regression, on the screen right now, there should be the same example. Graph may look a little different, but pretty much the same. You see here, it's perfectly made. It just continues going up. And you guys will be able to make this soon, this example. So just remember, turn on those notifications, guys. Now, so you see here how it increases in a curved state. That's what polynomial regression is. And the way that it works is pretty different, but not as different as you may think. And now I'll just quickly tell you guys the formula for you guys to understand. So on the screen right now, you should be seeing the polynomial regression formula, and you guys are probably very confused. Like, what is this? Why are there so many rows and stuff? Well, this way that I'm showing you right now is pretty spread out. And what it is, it's basically for me to explain it better to you guys. So you see here, it's y1 equals 1, x1 to the power of 2, until x1 max. So, and it just repeats on, continue on, and you see those dots, those 3 dots that are in many places. That just says that it's continuing on. Like, it says x1 and there's nothing on top for the first row. Like, there's y1, then there's 1, then there's x1, but then there's x1 to the power of 2, like that. And then you see those 3 dots. And then it goes to x1 and then m. M stands for max. And then there's this b0 plus e1. This part isn't as important, don't pay attention to that. But as you see here, it will continue on, and you see there's y2 for next part. 1, x2 instead of x1, x2 and 2, and continuing on to x2m. And it just ends up with yn, 1, xn, xn2, xnm. N just means null, like it's the infinite value. So the reason it's why this is so it can track all of the dots. Like, as for polynomial regression, it's really sporadic, as you guys know from the examples I've showed you. Like, the curves and all, it's not 100% known. So that's why this way it's like this. So this is probably pretty confusing, but don't worry about it. Like, what if you guys stay subscribed? Thank you once again. You guys will be able to see when my video on polynomial regression comes out. And when you guys see that, then you guys will be able to understand this formula a lot better, as I'll be showing you an actual programming example. So sorry that this video is a little longer, as this polynomial regression is a little more advanced. But if you enjoyed the video, please give us a like and subscribe. And with that said, I'll see you in the next video. Goodbye!